Bisection method is widely used because of its reliability, but like any numerical methods, it's come with both advantages and disadvantages. So today we will break down that where the bisection method excel and where it falls short. So stay tuned until the end to get the full picture. So let's get started. First of all, we are going to talk about the advantages of bisection method. So the very first advantage is that bisection method is very simple and easy to implement. The bisection method is one of the easiest numerical methods to understand and apply. It does not require complex mathematical operations or derivatives, making it accessible to beginners in numerical analysis. Secondly, we have second advantage is that bisection method is always convergent. This method guarantees convergence as long as we choose an interval where the function changes its sign. Since it systematically halves the interval, it will always move closer to the root, ensuring a solution is eventually found. Important advantage of a bisection method is error controlled. One of the biggest strengths of the bisection method is that the error can be controlled. With each iteration, the interval size reduces by half, meaning we can determine exactly how many steps are needed to reach the desired accuracy. Fourth most important advantage is safe and reliable. The bisection method is considered one of the safest numerical methods because it does not depend on the function's behavior beyond sign changes. Unlike the other methods, it won't diverge or give unexpected results due to poor initial guesses. Fifth one is we have work for any continuous function with a root. So this method can be applied to any continuous functions as long as there is a sign changes within the given interval. It does not rely on the functions being differentiable or smooth, making it versatile in many practical scenarios. Next, we are going to discuss the few disadvantages of the bisection method. The first disadvantage of the bisection method is slow convergence. One of the major drawback of the bisection method is that it converges very slowly. Since it only halves the interval at each step, it can take a large number of iterations to reach a high level of accuracy. Other methods like NR method or a secant method can reach the root much faster. The reason behind it that the rate of a convergence of bisection method is rate of convergence of bisection method is 1, or simply we say that the bisection method converges linearly. Bisection method converges linearly. Okay. Second disadvantage of the bisection method is cannot detect certain root. The bisection method depends on a sign change to work. If a function merely touches the x-axis instead of crossing it, like for example, we say that f of x is equals to x squared. So this method fails to detect the root because there is no sign changing, because the graph of x squared is like this. So that's why this method fail, because there is no sign changing. The sign of the x square is positive from this side, and again it touches the x-axis and then go upside to the positive. Next is we have the third disadvantage is that insufficient for close initial guesses. Okay, if we look this, even if one of the initial guesses is already close to the root, the method does not take advantage of this. It still follows its systematic halving approach, making it inefficient compared to the method that can rapidly refine the guesses. So it's better to choose the initial guesses far from the root from A and B both sides. The fourth disadvantage of the bisection method is not suitable for multiple roots in an interval. If the function has multiple roots within the given interval, the bisection method will only find one of them. It does not differentiate between multiple roots and cannot handle complex root structure efficiently. Fifth is does not use derivative information. So, unlike Newton's method, which uses derivative information to adjust the next guess more accurately, the bisection method ignores function properties beyond sign changes. So, this makes it much slower for well behaved function where better methods could quickly converge to the roots. So, the bisection method is a powerful yet simple technique that guarantees convergence and is easy to use. However, its slow speed, inability to detect certain roots, and inefficiency for multiple roots means that it is not always the best choice. So if you enjoyed this video, don't forget to like, share, and subscribe to my to more numerical analysis tutorials. So let me know in the comment if you would like me to compare the bisection method with other root finding techniques. So thanks for watching, and I will see you soon in the next video. Take care.